Okay, this lesson today we're going to talk about is applications of Trig to use navigation and surveying. So when they use surveying or navigation, they talk about a direction in degrees. They will always start, what I normally do on most problems is to make a crosshair, okay? And they will always start in the north, okay? And they will spin in this clockwise direction. So if the question said, the course of a boater is 110 degrees. You start at the north, this would be 90 here, and then you'd have to go another 20 to get to 110. So then that would be the angle that the boat would be going. Sometimes they talk about a plane going at a course of 270 degrees. Again, you start at the north, you go in this direction of clockwise. Again, if you had a crosshair here, it'd be 90, 180, 270. So we get all the way over to 270, which also, another way of describing this would be going to the west. Right, west, north, south. Yep, west. Okay? Let's look at this here. So a ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. 1 knot equals 1 nautical mile per hour. Then it changes course to 230 degrees, continuing at 15 knots for 3 more hours. At that time, how far is the ship from the starting point? So what I would do here is I have a starting point right here. I would make a crosshair. Okay, so I make a crosshair. Okay, and where am I starting at? 300 degrees. Okay, so if I start at the north, I would spin around in a circle. Okay, so a full circle, almost a full circle. If 360 is the full circle, how many degrees would I be left over with here? I'd be left over with 60. So 300 is the distance I traveled from north to here, and then there's 60 degrees left over to make 360 if I did a full circle. Okay? So 60 degrees would be there. Other things I like to label sometimes is this other angle here in this corner. Okay, so if that's 60, I know this makes a 90. That means this would have to be 30. And according to my drawing, that's not drawn very proportional, but as long as I label it correctly, we're good. Okay? Now its speed is going for 2 hours at a speed of 15 knots. Okay, so all I would do with this problem would be take 2 hours times 15 nautical miles per hour. That gives me 30 total miles that I would have traveled there. So then I'm going to label this as a 30. Okay? Once I go my distance, I then make another crosshair. So you always make a new crosshair every time you do a new direction. So these are done now. Okay, so so now it's a new crosshair then. It changes to a course of 230 degrees. So again, I start at the north, 90 would be here, 180 would be at south, 270 would be here, so it's in between there. So if this is 270, and this is 180, okay? First off, how many degrees would be left from here to here if 180 is there and I'm trying to get to 230? So I go 180 minus 230, and I'm left over with 50 degrees. So I'd have 50 degrees here in this spot, okay, which would make, if this is 230 to 270, that would make 40 leftover degrees there, which would make sense. Okay, the other thing I can label from this last problem is if this was 60 degrees, alternate interior angles tell me that this angle is also 60 degrees. Okay, so that angle there, from here to here, is also 60 degrees. Okay, so now what I can do is I know that this whole angle would add up to 1650 is 110 degrees. Okay, and let's keep going here. So it changes direction, so 230, I got that. Okay, so I've calculated 230. It continues at 15 knots for 3 more hours. So 15 times 3, that would be 45. Okay, and then what's the question asked for? At that time, how far is the ship? So the ship's out here. Okay, we've got the Titanic. Okay, from the starting point. Okay, what shape is that right there? got a triangle. So if I look here, I got a triangle. Things I know is this is 110 degrees, this is 30, this is 45. Can I now look at the triangle? You want to redraw it? That might make it easier for you. Okay, I want to know this side here. Well, law of sines would not work because I don't know an angle and its opposite. What I do know though is I can do the law of cosines. So c squared equals a squared, which is 45 squared, plus my other leg squared, minus 2 times 45 times 30 times the cosine of my included angle, which is 110 degrees. Okay, and then we can just use my calculator. So 45 squared plus 30 squared minus 2 times 45 times 30 times the cosine of 110. Make sure our mode is in degree mode. Okay, and then I hit enter. And now I get a big number. So c squared equals 3,848.45. But you always got to do the square root at the end. So then my answer will be second square root, second answer. And then my distance would be 62 miles. So it's 62 miles away from where it started. Okay? So now that's an example of what types of problems we will be doing. Here's an example of other ways of them telling us directions. Okay, so sometimes they're going to just give us a degree and we always start from the north. But other times it doesn't always have to be like that. It can be like this, where they say we have the direction of north 20 degrees east. So the north here means we start at the north, we go 20 degrees in this direction into the eastward direction. So we're going east, so it's 20 degrees to the east, and then that would be the angle here, would be 20. Okay, here it says we start at the north, we're going to go 50 degrees in the westward direction. So if I start at the north, I'm going to swing my line this way now in the westward direction, 50 degrees, and then that angle here would be 50. Okay, and my third diagram here, I start at the south, I go 30 degrees in the westward direction, so it spins in that direction, and then this angle from here to here would be 30 degrees. So that's another way of them giving directions for us. Okay, very often a plot of land is taxed according to its area. Okay, surveyors might do this to figure out the area of what they're trying to maybe build a road over or whatever it is. Farming, figure out how much land they have. So they have to find the area. Okay, so here's a story problem. It says from a granite post, that's a starting point here, so that's where I start. Proceed 195 feet east along Tasker Hill Road. Okay, so I'm going to guess that my post is right here to start. I always start with a crosshair. Okay, I'm going to go with a thinner line. Okay, so I always start with a crosshair. I'm going to proceed east, so I'm going to go all the way east here, and if you go north, south, east, west, north, south, east, west, okay, east is this direction, for 195 feet, east along Tasker Hill Road. Okay, I've done it, I'm going east, done. Okay, let's look at the next line. Then, so now I'm changing my bearing. Okay, so then, on a bearing of south, 32 degrees to the east, so that means I'm starting in the south, and I'm going 32 degrees to the east. So south is down here, 8, how about S? 32 degrees in the eastward direction, so this is 32 degrees there. Okay? Actually, what I'm going to do here before I do this, I'm going to make Tasker Road a little shorter. Okay? Let's try one more time. So I'm going to make my crosshair here, and I'm going to go south 32 degrees into the eastward direction. Other thing I can do right now is I can fill in this whole angle, because I know this is a 90 here. So 90 plus 32 is 122. Okay? And then I know that I went for 260 feet. Okay? So probably longer, it's supposed to be longer than Tasker Hill Road, but we're just going to go with this. So 260. Okay, I then always make a crosshair at the end when I change directions. So I know if this sliver was 32 degrees, alternate interior angles from geometry tell me that this angle right here is 32. Okay? So I went 260 along that. Okay, back up. Let me erase that. It then says then, so now it says then again, which means it's another crosshair. I'm going to go south 68 degrees to the west. Okay? I'm running out of room here. So I'm going to go south 68 degrees. So from the south, starting here, this angle right here would be 68 degrees. Okay, if that's 68, and then I got to fill out the rest, figure out the rest of the stuff. So I know if this made a right angle here, if that's 68 degrees, how would I find the missing angle? I'd go 90 minus that angle. Okay, so I would go 90 minus 68 degrees, and that's a 22. So I know that I have 22 degrees here. And then if this was 32 here, that's another right angle going from here to here. So 32 degrees, or 90, minus 32 degrees gives me the leftover of 58. So I'd have 58 degrees on the inside. Now the question is, what do I get for degrees altogether? So 58 plus that 22. So 58 plus the 22 would give me 80 degrees. So I now have 80 degree angle here. You always want to find out the angles. Once you make the angle, figure out what the angles will be on the inside. Okay, and how long will that one be? For 385 feet. So that's going to be way down here. 385 feet. Okay? And then finally on a line back to the granite post. So I don't have a bearing here, so I can't really figure that out. I do know that my post is up there. Okay, so I'm going to just draw my line down here to my granite post. Okay? So we need to find the area. Now what I might actually do on this problem is, now that I kind of know what it looks like, and it's so huge, I like to draw my pictures really big also, so that when we have all this mess of numbers, if you're writing in microscopic form, you're not going to be able to figure out what these numbers are. The bigger you make your picture, the bigger you're going to be able to see the numbers. So I like to draw a big picture, and then at the end maybe redraw it. Okay, so if you think about my picture now, I got a picture that looks something like this. I know this is 122 degrees. This is 80. And I know that this is 260. I know this is 385. Okay, and I know this is 195. Okay, and that's all the information I know. I'm going to group this right now. Okay, I'm going to do a new page. And I'm just going to move it over to this new page here. Now, let's read what the question says. It says, then find its area. So, now, we just drew it out, but does this look familiar to problems we've already done earlier in this chapter? And it should. Okay. It's a quadrilateral. We don't know how to find the area of a quadrilateral, but I do know how to find the area of a triangle. Okay? And in order to find the area of a triangle, I would have to make a line. Now, since there's no right angles here, I'm just going to split it like that. Okay? So in order to find the area of a triangle, what are the things I need to know? Area formula is 1/2 AB sine of the included angle. Right here, do I have an A and do I have a B? I do. So 1/2 of 195 times 260 times the sine of my included angle in between those, so 122. Okay, and then I can use my calculator here and just plug that in. So 0.5 parenthesis 195 260 sine of 122. Okay? That's a big area, but would make sense. Okay, so one of my areas, I'll write it down, 21,498 feet squared. Okay, we'll save that for later, and that's this area here. Okay, now the other triangle, I can't find the area yet because I don't know. So what I'm going to need to know here, if I do the other triangle, we'll call it the blue triangle. I'm going to have to find this angle, call it X, and this side, we'll call it Y, and then I'll be able to find it. Okay, I go off of this angle because this tells me nothing down here, and this tells me nothing up there. Okay, so let's go back to the red triangle. How would I be able to find this other missing side? Okay, and again, I have two legs and an included angle. I can use law of cosines. So for the red triangle, it would be c squared equals 195 squared plus 260 squared minus 2 times 195 times 260 times, it's a law of cosines, so the cosine of my included angle, which is 122. Okay, and again, you can just plug that one directly in there. So 195 squared plus 260 squared minus 2 parenthesis 195 parenthesis 260 cosine of 122. And again, make sure your mode is in degree mode. Okay, and I get a monster number. So I get c squared equals 159,358.8. But what do we have to do to that number? Gotta square root it. So second square root, to save you time, just go second answer. The negative sign of that number goes directly in there. And we get 399.2. So I now know the two legs that I'm going to use. So I'm going to use 385 as one leg and 399.2 as the other leg. I need to find my missing angle. So how could I find the missing angle? I could probably use law of sines, okay, because I have an angle on the side opposite. So I'm going to do a law of sines now. Okay, so I'm going to do, we'll do red since it's still that triangle. So it would be the sine of 122 over its opposite, which I now know is 399.2, equals, and I'm trying to find this angle, because if I can find this angle, I know the whole thing's 80, so I can just do the leftover for that blue angle there. Okay, so then now I'm going to do the sine of, we'll call it z here, so sine of z over its opposite, which is 195. So sine of z opposite of that would be 195. Okay, and then how do you solve this? We cross multiply. Okay, so I'd have 399.2 sine of z equals, whatever you get when you multiply sine of 122. So sine of 122, close it off, times 195. And that's 165. So 165.4. Okay, and then how do you get sine of z by itself up here? I'm going to divide by this 399.2, divide by 399.2, so I get sine of z equals a number. So take this number divided by 399.2. Okay, you get a decimal of 0.4142. And then how do we always find the angle using my calculator? Or how do I get rid of this? I do the sine inverse. And what you do to one side, you do to the other. So I'm going to go second, sine inverse of second answer. Just bring that number right back in there. And I get 24. So my angle right here is 24.5 degrees. So if that's 24.5, how do I find the other angle? If the whole angle is 80, I subtract this piece and then it'll give me the blue piece. So 80 minus second answer, that answer, gives me 55. So I now know that this angle right here in it for the x is 55.5 degrees. Okay? And now if I want to find the area of the blue triangle, I now have this leg and this leg. So I have two legs and the included angle. So it'd be 1/2 385 times the other leg, which is 399.2, times the sine, this is the area formula for a triangle, which we've already done, is 55.5. Okay, and then I just plug it in. So 1/2, 385, 399.2, sine of 55.5, and we get a huge area of 63,330.8 feet squared. Okay, and then how do I find the total area? I add this number with my red triangle up here, so plus 21,498, and my final total answer on this problem would be 84,828.8 feet squared. Okay, and that is the area formula, or the area of that plot of land. Okay, and then they can find the tax on that once they know how big it is. It's a long one, but I think it's easiest to, once you know what it looks like, redraw it and then make sure you have your room on there. Okay, I'll let you guys have this one if you're following the video. Maybe try it on your, pause it, try it on your own, and then hit play and I'll show you the answer. Okay, town T is 8 kilometers northeast of village V. So northeast would mean it's to the north and to the east. So actually it's going upward. Okay, over to here. So T is northeast of village V. So V is over here. North and east is normally split perfectly. So it's a 45 and a 45. Okay, village T is going to be here. And now I know these angles are both also 45 because they're alternate interior angles. Okay? T is northeast of V. Okay, and when you're done with, and it's 8 kilometers, so I can put an 8 there. Then it says city C is 4 kilometers from T. So C is from T, so you're starting at T on a bearing of 150. So 150 means you start at the north. Okay, so you start at the north, and you're going to go down. Well, 90 is there, and it doesn't go all the way to 180, so we're going to go to here maybe. So 150 degrees would be from here to there. Okay, well, how many would be left to get to 180 then? So 150 to 180 would be 30, so there's 30 leftover degrees there inside of here. Which then, what does that mean that angle is altogether here? 30 plus this 45 degree angle here gives me 75 degrees. Okay, and how many kilometers was that? It was 4. And we'll call that city C. Now the question is, what is the bearing? So now we need to know the angle. Bearing is the angle, and the distance from here back to here. Okay? So, we don't know this angle down here. What I'm going to do is I'm going to again redraw my triangle. We'll draw it in black. And then label the things I know so I can kind of see what's going on here. This is 75, this is 4, that's 8. Okay, so here's the information that I know from that triangle. It makes it a little simpler. I want to find the distance, so I want to find this value over here, x, that's the distance. And then the bearing would be like the angle. So we're probably going to have to find this angle, we'll call it angle y. Okay? So again, log cosines, 2 sides of the angle, so I'm going to use log cosines first. So c squared equals 8 squared plus 4 squared minus 2, 8 times 4, times the cosine of my included angle, which is 75. And what's great about this problem is I can plug it directly in my calculator. So 8 squared plus 4 squared minus 2, parenthesis 8, parenthesis 4, cosine of 75. Okay, and that's 63. Now that's c squared equals 63.44. So then you got to take the square root of that. So second square root, second answer and it's 7.96. So the distance here would be 7.96 miles, I'm guessing, kilometers, I don't know. What does it say here? Kilometers. Okay, so I found the distance. I now need to find the angle. If I know this is 7.96, can I now do law of sines? And I can. So I'm going to do sine of 75 over its opposite, 7.96, equals the sine of y over its opposite, which is 8. Okay, then I'm going to cross multiply here. So sine of 75 times, close out the parenthesis, 8. Okay, so now if I were to just solve this and keep going, I'd have 7.96 sine of y equals 7.727. Okay, I would divide by this. Again, we've done all these already, so that's why I'm going through it pretty quick. Okay, we should know how to solve using the law of sines. We take 7.72 divided by 7.76. 7.96, sorry. Okay, and you get that decimal. Okay, so 0.97. And then you take that, and how do we always find the angle? You gotta do the inverse. So second sine inverse, second answer. Okay, and my angle there would be 76. So 76.1 degrees. Okay? So now let's go back up here and let's try to figure this out. So 76.1. So this angle here, total is 76.1. Okay, they want us to go back here, so let's get rid of my calculator. It says, what is the bearing and distance from C, or of C from V? Ooh, I did it wrong. That's alright. Okay, if I'm going from V, I actually need to know this angle. That's alright, we can find that. How do you find this missing angle if I know two of the angles? Okay, you add them up and subtract from 180. So I take this number plus 75 and get 151, and then I subtract that from 180. Okay, and I get 28.9, we'll say. So this angle is actually 28.9 degrees. Okay, so if I want to talk about the bearing, okay, and I want to figure out what this green line is, that bearing would be. Okay, think about my crosshair here. Okay, how far would it be from here down to here? Well, I know from here to here it's 45, and then I know from here to the green line is 28.9. So what am I going to do with those two numbers then to find the total distance for that bearing? I would add them. So 45 plus 28.9 gives me a bearing of 73.9 degrees. Okay, so what is my bearing? My bearing would be 73.9 degrees. And then you could do this too. You could go north 73 to the east because it goes in the eastward direction if you want. And then the distance would be 7.96 kilometers. Okay, so we got that there. Alrighty, questions on that? Let's check the book and see if I did it right. Okay, and then let's go to the next question. Yeah, that's right. Alright, last question here, I think. A plane flies at 600 kilometers at a course of 300. So again, I make a crosshair. Start at the north. So 180, 270, 300 is actually going to the upper left, so I'm going to go down here. So 300. If that's 300, that means I have how many more to get to there? Okay. How far would that be? 360 is the full circle, 300 is here, that means I have 60 degrees left over there. Okay? So, if that's 60, okay, I'm going up in the upward direction. And I'm going to have another crosshair because I'm going to have to change directions. Now if this is 60 from here to here, I also know that this is 60 from there to there. Okay, I know it flies 600, so I would label that 600 kilometers. Okay, what else do I know? If that's 60, then I know this is actually 30 because that makes a right angle here. Okay, and if this is 60, I know this is 30. I like to fill those in right away. Okay, then it flies south. When it says flies south, south is directly this direction.